Researchers assert in a bold statement, they have discovered a brand new planet that defies all known concepts. NASA, famed for its groundbreaking discoveries, has revealed that this planet is extraordinary, not only due to its size and position, but also because it produces light that appears to be fake. Could this be the beginning of unraveling mysteries that could radically alter our understanding of the cosmos? Is this finding suggesting the possibility of extraterrestrial life? By delving into NASA's incredible revelations, we might soon learn the truth about these unusual lights. In 2007, NASA launched the Dawn spacecraft with the goal of investigating some of the most enthralling bodies in our solar system. Armed with 3 ion propulsion engines, Dawn embarked on a journey that began with a 14-month investigation of Vesta, the second-largest asteroid in the belt. Dawn returned high-resolution photographs and data which unveiled Vesta's intricate surface and a wide range of geological history. After the mission at Vesta was completed, Dawn continued with the second, and possibly more exciting, phase of its mission, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to break free from Vesta's orbit and journey toward Ceres, a feat that conventional chemical drive systems would not have permitted. These engines maintained a gentle, steady thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, positioned between Mars and Jupiter. For a long time, it was regarded as the smallest dwarf planet in the solar system, until it was reclassified in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, and one of the most intriguing due to its unique features. Scientists eagerly awaited the first close-up images of this mysterious world, which revealed a scattering of bright spots across its surface, particularly within a large crater known as Arcata. These bright spots immediately captured the interest of scientists and sparked substantial speculation in the scientific community. Prior to dawn, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. There was little awareness of this dwarf planet, and the chances of getting high-quality close-up images promised exciting new discoveries. The Dawn mission aimed to enhance our comprehension of the formation of the solar system and the role of water in the development of planetary bodies. The bright spots on Ceres, also observed elsewhere on asteroids, could be made of highly reflective materials, salts left behind by evaporating water. Based on this finding, the possibility of cryovolcanism on Ceres emerged, a process where volcanoes spew brine or water instead of molten rock. But what exactly are these enigmatic lights, and what do they reveal about Ceres' nature? Could they be an indication of ongoing geological activity, or something even more extraordinary? Ceres is distinct from other bodies in the asteroid belt because of its size, mass, and composition. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, indicating that it could supply additional insights into the origins of the solar system. After 2 years of travel, the Dawn spacecraft finally arrived at Ceres in early 2015, marking an important milestone. It was ready to deliver the first close-up shots of the largest object in the asteroid belt. As Dawn neared Ceres, the images became clearer and more detailed, revealing a world that had long been a mystery. The first images showed a surface filled with craters, evidence of a long history of impacts. But what truly captured the attention of both scientists and space enthusiasts were the enigmatic bright spots scattered across the rocky terrain. As the resolution of the images improved, the scientific community began to speculate on the nature of these spots. Were they patches of ice reflecting sunlight, or could they be something even more unusual? Theories ranged from mineral deposits to possible indicators of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity, but rather a collection of several distinct spots. The most widely accepted explanation is that these are salt deposits left behind by the sublimation of water. This suggested that Ceres may have, or still has, some form of geological activity, bringing water or brine to the surface, where it quickly vanishes, leaving behind reflective salt residues. These findings challenge previous assumptions about Ceres, presenting it as a much more dynamic and complex world than initially considered. The possible existence of underground water or brine pockets raises profound implications for the potential for life in our solar system. Ceres is an intriguing dwarf planet, often described as an icy world with a surface that is porous yet rocky, unlike the majority of asteroids, which are primarily composed of rock and metal. Ceres stands out due to its unique composition. Its surface is a mixture of hydrated minerals and water ice, including clays and carbonates, which makes it lighter than its rocky counterparts. This composition suggests that Ceres includes a substantial amount of water. Its surface is rocky but porous, with ice and other volatiles trapped beneath, making it look more like a comet than a typical asteroid. The tiny planet is believed to have a unique interior made up of a mantle and a core rich in water ice, which may constitute about half of Ceres' total volume. Its mantle is probably a blend of rock and brine, encasing a core that could consist of denser materials like silicates. The presence of a large amount of water ice suggests that Ceres may have hosted liquid water in the past, particularly if radioactive decay heated its core during its early history. This internal structure distinguishes Ceres from other asteroids and raises fascinating inquiries regarding the potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that this dwarf planet may have formed in a cooler area of the solar system and later migrated inward. Ammonia may lower water's freezing point, which supports the idea that surface brines could still exist. The composition and history of Ceres not only improve our comprehension of this enticing world but also provide important clues about the processes shaping and evolving icy bodies across the solar system. Cryovolcanism is a fascinating and relatively rare geological phenomenon, especially when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, eject materials like water, methane, or ammonia. These substances can exist as liquids or gases in extremely cold environments. Cryovolcanoes on Ceres function by allowing water mixed with dissolved salts to reach the surface. As soon as the salty water contacts the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid to gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots observed. These groundbreaking conclusions have not only reshaped our understanding of Ceres but have also opened new doors in the search for habitable environments beyond Earth. The implications of active geology, particularly cryovolcanism, suggest that Ceres is not a dead world, but one that is still evolving. As scientists analyzed data from the Dawn mission, they began to identify seasonal variations in the bright spots, which further supported the idea of ongoing subsurface processes. Changes in brightness over time hinted at cycles of sublimation and redeposition of volatile materials. This finding was remarkable, as it implied that Ceres might have a dynamic interior system, possibly with brine reservoirs close to the surface. In addition to water and salt, scientists detected organic molecules on the surface of Ceres. These carbon-based compounds are the building blocks of life, and their presence raised thrilling possibilities. Though not direct evidence of life, their discovery reinforced the idea that Ceres holds many of the key ingredients necessary for life to develop under the right conditions. Furthermore, gravitational data collected by Dawn allowed researchers to model Ceres' internal structure with greater precision. The results suggested the presence of a low-density layer beneath the crust, possibly composed of briny liquid, another clue pointing toward a complex internal system. All of this data, from surface composition and geological activity to the presence of organics, paints a picture of a dwarf planet far more complex and intriguing than previously imagined. Ceres may not be just a relic of the early solar system, but a potentially active world with characteristics that echo those of icy moons like Europa and Enceladus. As Dawn completed its mission, entering a stable orbit around Ceres where it now silently remains, its legacy lives on. The information it provided has transformed a faint dot in the night sky into a world of mystery and potential. Ceres now stands as a symbol of how much we still have to learn about our cosmic neighborhood. It invites us to keep asking questions. Could microbial life ever have existed beneath its surface? Are there still liquid reservoirs hidden within, waiting to be discovered by future missions? What other secrets lie in the ice and rock of this distant world? One thing is certain: Ceres, once thought to be just another asteroid, has become one of the most captivating objects in the solar system. And with future exploration, it may yet prove to be a crucial piece in humanity's ongoing quest to understand our place in the universe. Surface processes on Ceres. Ceres is currently regarded as an intricate and dynamic world, rather than the inactive body it was once thought to be. The realization of bright spots spread across different regions further suggests that Ceres may be experiencing ongoing geological transformations, with potential implications for its future and for a more comprehensive understanding of icy craters that cover celestial bodies. In addition to the bright spots, Ceres' surface reveals much about the planet's turbulent surroundings. These impact craters serve as a historical record, shedding light on the occurrences that have shaped Ceres' surface over millions of years. As Dawn returned more detailed images, scientists were able to identify an astonishing variety of surface features that were previously hidden. Each of these craters tells a different story, providing valuable information about Ceres' evolution and geological history. The mission to investigate the uniqueness of Ceres' features continues to inspire interest among scientists and the general public alike. It's not just about particular craters or bright spots. This mission has opened up new avenues for understanding the wider dynamics of the solar system. While there are still unanswered questions, the discovery of potential cryovolcanic activity has demonstrated that Ceres is far more active than initially assumed. The evidence of water, brine, and possibly even the potential for life provides exciting prospects for future exploration. According to many experts, the ongoing investigation into Ceres will eventually lead to even more profound revelations about its history, its potential for life, and the forces at play beneath its surface. This exploration is essential for expanding our understanding of other planets and stars, particularly those which, like Ceres, could provide the necessary components for life. In the years to come, scientists will likely focus on further investigations into Ceres' cryovolcanism, its subsurface, and how long water or brine can persist there. As we continue to study the solar system's outermost regions, missions like the Dawn spacecraft will remain at the heart of unlocking the mysteries of distant worlds. The exploration of Ceres and other similar bodies provides a glimpse into the diversity of planets and moons that may hold the answers to some of the universe's most pressing questions. Right now, the mystery of the bright spots on Ceres is just one more piece of the puzzle in our solar system's evolution, leaving researchers and adventurers eager to learn more about the possibilities of existence on other planets. If this mission has proven anything, it's that there's still so much we don't know about the planets, moons, and asteroids that surround us. Ceres holds serious potential for harboring water, and its unique geological features show that even the most unlikely places could one day be vital to understanding life elsewhere in the universe. The ongoing discoveries made by NASA's Dawn mission will continue to influence our perception of the cosmos and motivate future research into the unknown. Who knows what other unexpected revelations await us in the midst of space? Only time will tell, but the search for answers continues. As the Dawn spacecraft journeyed closer to Ceres, new revelations about the dwarf planet began to unfold. The bright spots that initially excited the scientific community were not just intriguing anomalies, they suggested a deeper, more intricate narrative developing on Ceres. Scientists had long speculated about the possibility of brine or water existing on this distant world. The discoveries made by Dawn confirmed that these ideas were worth further exploration. The presence of salts and the reflections of light from these spots suggested that Ceres might still harbor traces of water beneath its surface, possibly within pockets of ice or brine. The potential of cryovolcanism on Ceres opened up a wealth of possibilities for understanding geological activity on other icy bodies in the solar system. Cryovolcanic activity, rather than conventional volcanic eruptions, involves the eruption of water, ammonia, or other volatile substances instead of molten rock. This phenomenon has already been found on moons like Enceladus and Europa, where geysers of water are released into space. But Ceres presented a new frontier. The evidence of similar activity, in the form of sublimation and salt deposits, showed that this process may be more prevalent throughout the entire solar system than previously thought. What made Ceres even more intriguing was its composition, which suggested that it could be significantly more than merely an asteroid or typical dwarf planet. Unlike other rocky bodies, Ceres has a particular combination of water, hydrated minerals, volatile substances, and ice compounds. This extraordinary mix made Ceres an object of increasing significance for researchers studying the history of the solar system. That Ceres contains so much water, in the form of ice and brine, complicates our understanding of the role that water plays in the development of celestial bodies. Could Ceres have once been a more habitable world? Could its subsurface still host liquid water, making it a potential candidate for life? NASA's Dawn mission brought us closer to answering these questions, and the data it collected will likely fuel scientific research for years to come. As more images and analyses of Ceres' surface were sent back to Earth, new features began to emerge, previously unseen. The surface of Ceres was revealed to be much more varied and complex than scientists initially thought. The diversity of craters, cracks, and surface features painted a picture of a world shaped by countless impacts and forces over millions of years. Some of the craters, in particular, held clues about Ceres' internal structure and its potential for active geology. Moreover, the size of these craters suggested Ceres had experienced significant collisions in its distant past, shaping the current appearance of its surface. These ancient collisions not only altered the physical appearance of Ceres but may have also contributed to the internal heating necessary for cryovolcanic activity. Some regions show signs of resurfacing, possibly the result of subsurface movement or brine upwelling, which hints at internal dynamism that scientists are only beginning to understand. One of the most notable features identified by Dawn was a crater, home to some of the most prominent bright spots on Ceres. Detailed studies revealed that these bright areas are composed largely of sodium carbonate, a type of salt left behind when briny water reaches the surface and evaporates. This finding confirmed that liquid water once reached the surface in geologically recent times, perhaps even in the last few million years. The existence of relatively recent cryovolcanic activity changes our understanding of how small celestial bodies evolve. It challenges previous assumptions that dwarf planets are geologically dead and demonstrates that even these remote, cold worlds may have active internal processes driven by residual heat, radioactive decay, or the insulating effects of a thick icy crust. In light of these discoveries, the scientific community has renewed its interest in Ceres. Discussions are underway about the possibility of future missions, including orbiters or even landers, that could study its subsurface composition in greater detail, possibly using radar or drilling technologies to probe beneath the crust. Additionally, the presence of organic compounds on Ceres has intrigued astrobiologists. While these compounds do not directly indicate life, they are essential building blocks for it. When combined with water and energy sources, they create an environment that may support microbial life, either now or in the past. Ceres has thus become a key target in the broader search for habitability in the solar system. It represents a fascinating middle ground between rocky planets and icy moons, offering a unique laboratory for understanding how water behaves in low-gravity environments and how internal processes shape planetary surfaces over time. As the legacy of the Dawn mission continues, Ceres stands as a reminder that our solar system is still full of mysteries waiting to be uncovered. The dwarf planet, once dismissed as just another asteroid, now holds a prominent place in planetary science. It encourages us to keep looking deeper, to ask more questions, and to never assume that stillness means inactivity. The story of Ceres is far from over. With each new image, each new data point, the picture becomes clearer, and yet, more complex. In the grand narrative of space exploration, Ceres has earned its own chapter, one filled with ice, salt, mystery, and the quiet possibility that life, even in the most unexpected places, might one day be found.